Hello and welcome to the video on rectangles. By the end of this video, you should be able to describe what a rectangle is and show how you know that some quadrilateral is indeed a rectangle. Let's start with the definition of a rectangle. A rectangle is a parallelogram with four right angles. Now that definition tells us a few things. First of all, it tells us that this rectangle ABCD has four right angles. So angle A, angle B, angle C, and angle D are all 90 degrees. Well, without even looking in the definition here, I should be able to tell that this quadrilateral is then indeed a parallelogram, because one of the properties of parallelograms was if I could show something had opposite angles that were congruent, then it was a parallelogram. So in this case, since angle A and angle C are congruent and angle B and angle D are congruent, they're both 90 degrees, then this thing has to be a parallelogram. And that idea is fairly important here, because if I know something is a parallelogram, then all those properties on our previous video, all those properties of parallelograms are true for a rectangle. So without knowing anything else here about this rectangle, I know that because it's a parallelogram, it has opposite sides that are parallel, it has opposite sides that are congruent, it has opposite angles that are congruent, so angle A and angle C are congruent, and angle B and angle D are congruent. It has consecutive angles that are supplementary, so for example, angle A plus angle B would have to add up to 180. It also has diagonals that bisect each other. So if I would draw the diagonals in here and have this point of intersection be called point E, that the length from A to E and the length from E to C are equal to each other. And the same thing with the length from B to E and the length from E to D. And now with our new definition here, I know it also has four right angles. So the idea that a rectangle is a parallelogram is extremely important. To try to help visualize that, we're going to make a Venn diagram here. If this is the whole set of all polygons, well, inside this set called polygons, there were a bunch of different shapes. There was a set of objects called quadrilaterals, and a set of objects called triangles, and a set of objects called pentagons, and a bunch of other types, which I'm not going to take the time to draw in here. But to visually show how this works here, the parallelograms would fit completely inside of quadrilaterals. It would be a subset. So every parallelogram is a quadrilateral. It's completely contained inside it. Well, rectangles is basically going to fit inside the parallelograms. Every single rectangle is a parallelogram. A lot of times when you first hear the names of these things, you think they're completely different objects, but really a parallelogram and a rectangle are not completely different classes of things. Really, one is a subset of the other. A few properties of rectangles. If I know something is a rectangle from our definition, I knew it had right angles, but also if something is a rectangle, then I know that its diagonals are congruent to each other. What that means is that the length from E to G and the length from F to H are equal to each other. Well, the converse of that idea is also true. Not only is this object being a rectangle tell us that the diagonals would then be congruent to each other, if I could show that the diagonals of a parallelogram are indeed congruent, then that would be enough information to tell me that that parallelogram has to be a rectangle. Let's try a few examples. Find x and y so that each quadrilateral is a rectangle. Problem number one, we know the length of ET, well, that's the length of one of these diagonals here. We know that length is 3x minus 7. And I know the length of our other diagonal, RC, so that length right there is x plus 5. Well, one of the properties we just went over for a rectangle was that its diagonals are congruent to each other. So that 3x minus 7 has to equal the x plus 5. And now I just need to solve for x. To do that, I need to subtract my x from both sides, and then add my 7. And after I have 2x is 12, I can divide by 2 to get x is 6. You can quickly double check to make sure you got that right. X plus 5 would be 11 units, and 3 x's would be 18 minus the 7 would be 11 units that way as well. So since they both did turn out to be congruent, we know we got that first problem right. Problem number 2, if the measure of angle ECR is 2y minus 3, well, ECR is that angle right there. And the measure angle TCR is y plus 5. Well, TCR is its partner over here. We want to figure out what the measure angle ECR is. Well, again, one of the properties of a rectangle is that it has 4 right angles. So I know that this angle right here has to be 90 degrees. So to solve that out, I can just add my 2 angles together, because I know these are complementary, and set that equal to 90. Combine my like terms. I get 3y plus 2 is equal to 90. So 3y is 88 after I subtract 2 from both sides. And when I divide by the 3, I get y is 29 1/3. Again, you can plug that back in if you wanted to. 29 1/3 plus the 5 would make angle TCR 34 1/3. And 2y's minus 3, 229 1/3 would be 58 2/3. And then when I subtract the 3, I get 55 2/3 degrees. Make sure we're right when you add 34 1/3 and 55 1/3, you do get 90 degrees. So our answer here, what was the measure of angle ECR? Well, the measure of angle ECR is 55 2/3. All right, let's move on and try another example. In example number 3, we want to graph this quadrilateral and determine whether or not it is a rectangle. Let's start by just graphing our points. Point A is at a -5, 3. Point B is at 1, -1. Point C is at a -1, -4. And point D is at a -7, 0. Well, there's really 2 ways to show that this is a rectangle. The first is to first show it's a parallelogram, and we can use any of the methods to do that in the past. I could show that its opposite sides are parallel, or opposite sides are congruent, or its diagonals bisect each other. Once I know it's a parallelogram, I could then find the length of both of its diagonals. I could do the distance formula on A to C and the distance formula on the length of B to D. If this thing is a parallelogram, if those 2 diagonals turn out to be congruent as well, then I know it is a rectangle. Well, in this case, I'm not going to do that extra work. I'm going to do this problem a different way. Let's start by using slope to figure out if this thing is a parallelogram. To figure out if it's a parallelogram, you have to check and see if opposite sides are parallel. So again, it's going to be 4 slope formulas. The slope of AD is going to be 0 minus 3 over a -7 minus a -5. I get a -3 over a -2, or 3/2. The slope of BC, if this thing is a parallelogram, would be the same thing. So find the slope of BC. I get a -4 minus a -1, and I put that over a -1 minus 1. I get -3 over -2 again, which again is 3/2. I now know I have one set of sides that are parallel to each other. I'm going to do that same thing with the other set of sides, the slope of AB. When I take A and B and I subtract the y values and subtract the x values, I get a -4/6, which is a -2/3, and I get the slope of DC by doing 0 minus a -4 and a -7 minus a -1. I get 4 over a -6, which is also a -2/3. So I've shown that those other sets of sides are parallel to each other. So now at this point, if I wanted to do 2 distance formulas, I could show that the length of AC and the length of BD are equal to each other. But if the method I chose to prove that this thing was a parallelogram was using slope, I really don't have to do any extra work. Here's why. If you remember from algebra, there was a certain pattern about slopes. If I could show that 2 slopes were the exact same thing, that told me that these lines were parallel to each other. So that's how I knew that these 2 sets were indeed parallel. Well, there's another thing about slopes that we learned back in Algebra 1, and it's that the product of 2 slopes, if they turn out to be a -1, then those 2 lines are perpendicular to each other. So without doing any extra work here, when I take the 3/2 that those first two lines were for slope, and I times it by a -2/3, I get a -6/6, which is a -1. Well, that tells me that these are indeed perpendicular, and we know perpendicular means they intersect to form right angles. So without really doing any more formulas, I can quickly show, because the product of those was a -1, then these are indeed right angles. So I now know that this is a rectangle. And that concludes our video on rectangles. I hope you have a wonderful day.